In this lesson, in this video, I'm going to be discussing about IPv4 addressing. And in this lesson, we are going to focus more on Class C subnetting. So I'm hoping that this video I'm making is going to be the best subnetting video on YouTube. So I'm going to pull up nice slides on here that I've put together to explain subnetting for even for layman. I mean layman, those who are not even in the field of IT. I want to pull up this. I want to put up these slides and this video for them on YouTube in such a way that whenever they stumble against this video, they are able to understand what IPv4 subnetting is all about. So I'm really hoping that this video is going to be the best when it comes to subnetting. And when I mean the best, it means the video, the subnetting video that will make it the most simple to understand. So that is what I'm hoping for this video. I've read a lot of text and I've watched videos and I've watched how people are subnetting, and it takes me long time. It takes me about, let me say, 2 years to understand subnetting. It takes me about 2 years to grasp it. And now that I've grabbed it, I'm pulling up this video based on my experience, based on my knowledge, to explain IPv4 subnetting to people who are just coming into the field of IT. So that is my purpose, and I hope it's going to serve its purpose when I give my explanation. And also to my colleagues in school, my course mates, that we are doing some networking together at the University of London, mate. I want any networking student, if luckily, if they are lucky to stumble against this video, I want them to watch this video and understand subnetting, so that whenever they are going to be having practical examination or theoretical examination or CCNA examination or any IT course that has to do with IPv4, they are able to go in there and just pass it once and for all. And then even when it comes to interview, job interview, if for any reason you are asked to subnet, you are able to do it confidently and easily. I'm really open. I'm really open. Fingers crossed. So let's start. Like I said, it's going to be IPv4 address, but we are going to I will try as much as possible to emphasize more on Class C today in this video, and in subsequent video I'm going to do Class A and Class B. So this video is going to take more than an hour, and once it's reached up to an hour, I will have to stop and then start another one. That's what I'm going to do. So let's go ahead with this now. These slides, I put them up because I believe this is the best way to put up the slides for you in order to understand subnetting, and I'm serious. It is these slides. It has actually taken me 24 hours to 2 days in order to be able to bring this up, because I had to think what to explain first before the other, so that you can then add everything together to understand subnetting. So the first thing on my slides now says decimal to binary conversion. Binary is the framework of subnetting. So if binary is the framework of subnetting, that means we need to know how to convert decimal number to binary, and that's what we are going to do first. And to do that, why do we have to understand how to convert decimal to binary? This is because computers don't understand decimal numbers. because it's not easy for us as human to read 111100101110, which are binaries, because it's not easy for us to read it. That is why we always have IP addresses in decimal form. So for this reason, we are going to learn how to convert from decimal to binary and from binary to decimal. Computer understands binary. That's why we need to understand the language of the computer in order to be able to be a subnetting guru. So I'm going to remove my slides and I'm going to go to Word, and then the first thing we want to do is to do binary and decimal conversion to binary. So I'm going to say decimal to binary. That's what we want to do now. Decimal to binary. And then let me change the size so that I can have 14, 16 is fine. Now, in order to convert anything from decimal to binary, decimal numbers are numbers from 0. Decimal numbers are numbers from 0 to 9. So binary numbers are numbers from 0 to 1. From 0 to 1. Those are binary numbers. So example of a decimal number are 139, any number, 80, 10, 2, 4, 5, 6, 7. Okay, let me start from 2. So let me take this off. I'll just say from 2 to any number. That's from 2 to any number. They are decimal numbers. An example of binary numbers is just if you see 0 to 1. So we can only have 0 and 1. So decimal numbers are numbers that are less than 2. Less than 2. That's what binary numbers are. And these numbers, what's it called? Decimal numbers are numbers from 2 to any number. I think you understand that. Now, let's write out any decimal number, and we have to convert it to binary. Remember, IP address is written this way. I will just pick any one. IP address is written any number. So 192.168.10.0. This is a network address, and you should know that all the numbers 192 is decimal, dot 168 is a decimal, dot 10 is also a decimal, and dot 0 is also a decimal. It's also a decimal. Yeah, that's what it should be then. So dot 0 is also a decimal. Okay, now that we know, how do we convert any IP address to a decimal number? To convert any IP address to a decimal number, there's a formula, and that formula is never going to change. It's been used from ages ago, and we are still using it, and we will continue using it, and it's going to remain that. So to convert it, you have to know this offhand. 128 128 divided by 2, 64, divided by 2, 32, divided by 2, 16, divided by 2, 8, divided by 2, 4, divided by 2, 2, divided by 2, 1. Now, this is the formula for converting any decimal number to binary. Now, let's do 192 first. So to do 192, let me get my calculator, and I'll make it a bit smaller so that we can fit it on our screen. Now, to do this, I want to do 192 first. The first question I'm going to ask you is 192 greater than 128 or 128 greater than 192? Obviously, 192 is greater than 128. So what I'm going to say is, let's take 128 out of 192. So 192 minus 128. So since that is possible, since 120 we can take 128 from 192, this is going to go on. We are going to put 1 there, which means that bit is on. Okay, so if I go back to my calculator, after I've done that, after you've taken 128 from 192, I am left with 64. So I'll say 64 is 64 greater than 64? No. Is 64 equals to 64? Yes. So when the number is greater than or equals to, you put a 1. So because the number is equals to now, I'm going to put a 1 here. And if you say 64 minus 64, that's 0. If that's 0, that means I don't have anything anymore. All these are going to be zeros. All these are going to be zeros. That's what this is. That's what this is. Let's do 168. Let's do 168 together again. And 168 is, let me clear this, and we're going to say 168 greater than 128? Yes. So we're going to say 168 minus 128. Yeah, that is 40. So which means here I'll come down and put what here? A 1. Okay, because I'm able to take 128 from 168. So let's go back to our calculator. I'm left with 40. Now the question is 40 equals to or greater than 64? Obviously, 40 is less than 64 and it's not equals to 64. Since the number I'm having, since 64 here is greater, so that's going to be 0 because we can't take it. We want to make sure we can always remove, so we can't. So that's going to be turned off. That bit is going to be off. So I have 40. Is 40 greater than or equals to 32? Yes, 40 is greater than 32. So if I do minus 32, I'm going to have 8. So that means this bit is going to be on because that bit goes in there. After I've done that, I'm left with 8. 8 is less than 16. So this means this bit is going to be off also. And I'm left with 8, remember. 8 is equals to 8. Yes, so that bit is going to be on also. So I'm left with nothing. So this is going to be 0, 0, 0. Now, let's do 10. 10 is easy to do. To do 10 now, I'll say, because 128 is greater than 10, that's going to be 0, because I can't do that. 64 is greater than 10, that's going to be 0. 32 is greater than 10, that's going to be 0. 16 is greater than 10, that's going to be 0. 8 is not greater than 10, so I can take 8 out of 10, that's going to be 1, and I'll be left with 2. 4 is greater than 2, so I will put 0, and then 2 is equals to 2, 1, and I don't have anything again, that's going to be 0. And the last one is what? 0. So everything is going to be 0 here, because they are all greater than 0. Now, if you are asked, what is the binary conversion for this? So the binary conversion, you pick 128 first. So picking 128 is 11000000 dot 168, which is this now. 168 is 10101000. Let's pick 10 now. 10, which is this, is 00001010, and 0 is 00000000. Is that it? 1 2 3 4 5 6 7 8. That's it. So this is the binary conversion for this. We have just done it. So this is the answer for that. Okay, let me take this off again, and let's do something else. If you are given another binary, another IP address, let's do 128.10.150 dot 2. Let's do this binary. Let's do this again. So to do this, we are going to say, you can see the first one is 128, and we have 128. So 128 in 128 is 0. So I have 1 that is turned on, and I'm left with nothing. Every other bit will be 0. Let's go to the second one, which is 10. So to do 10, 128 is bigger than 10, we have 0 here. 64 is bigger than 10, we have 0 here. 33 is bigger than 10, we have 0 here. 16 is bigger than 10, we have 0 here. 8 is less than 10. So we can take 8 out of 10, and we'll be left with 2. So that means this is going to be turned on, 1. So 4, I'm left with 2. 4 is bigger than 2, and I have 2 there, so 2 is 1. So I'm left with nothing. This is going to be 0. So now the third one, which is 150. For 150, let's use our calculator for this. So we are going to say 150, because we know 150 is greater than 128. So we are going to say 150 minus 128. We are left with 22. So this is on. 64 is greater than 22. This is off. 32 is greater than 22. This is off. 16 is less than 22. So this is going to be on, and we are going to be left with 6. If we take 16 out of 22, we are going to be left with 6. So 8 is bigger than 6, 0. We are left with 6, so 4 is there. So we are going to turn this on, and we are going to be left with 2 now, because 6 minus 4 is 2. And then we have to turn that on, and we don't have anything again. And lastly, we have dot 2. So this going to be 0, because 128 is bigger than 2. 64 is bigger than 2. 33 is bigger than 2. 16 is bigger than 2. 8 is bigger than 2. 4 is bigger than 2. Then 2 is equals to 2. And then the last one, we don't have anything again. So the binary conversion for this decimal value is the first line 1000. So we put it there, 10000000. That's the first one. Dot the second one, which is 10, 00000101. So 00001010. That's the second one. The third one, which is 150, is 10010110, and the last one is what? 2. So we are going to have 1 2 3 4 1 2, and that's what we have. So everything in here has been replaced back here. So this is how you convert binary to decimal. This is how you convert decimal to binary. Let's go back down again and do one more example. Let's say you have let's say you have 20.168.0.0. dot 1. What is the binary conversion for this? So we are going to take this off again, and we are going to say, to do that, we are going to say 20. Remember, 128 is bigger than 20, so we can't do anything, that's off. 64 is bigger than 20, we can't do anything, that's off. 32 is bigger than 20, we can't do anything, that's off. 16 is not bigger than 20, 20 is bigger than 16, and if we take 16 out of 20, we are going to be left with 4, so this is going to be on. And 8 is bigger than 4, so we can't do anything, that's going to be 0. And 4 is equals to 4, that's going to be 1, and then we are left with nothing. So let's do 168 now, which is the second one here. So 168, 128 is lesser, is smaller. So 168 is bigger. So we are going to use our calculator and say 168 minus 128. We are left with 40. So first of all, this is 1, and we are left with 40. And then 64 is bigger than 40, so we can't do anything there. This is going to be 0. And then from 40, we have 32. If we take 32 out of 40, we are going to be left with 8, so this is going to be on. And 16, we are left with 8. 16 is bigger than 8. And this is where our 8 is. This is going to be on, and then the rest are going to be 0. And dot 0, simply by now, you should know dot 0 is this. And dot 1, simply you should know dot 1 is this. Remember, dot 1, all these numbers are bigger than 1, except for the last one, which is equals to 1. So the answer to this is get 20, which is 0001 0100 dot 10101000 dot 0000 dot 000001. So this is how you do decimal to binary. Now, if we want to do binary to decimal, it's very, very simple. Okay, it's very, very what? Simple. So what I'm going to do that is, let me just change all this color to red, and I'm going to change this to red. So I want to do the other way around. Remember, this number, if you add this number that is on, 1 is on here and is under bit 16, 4 is under bit what? Bit 4. If you add 16 and 4 together, that's going to give you what? 20. So this is 20 here, that's the first one. Let's do the second one, 168. How do we know if we are correct? So we are doing binary back to decimal now. Let's change this color to red because it's on. This to red because it's on. This to red because it's on. If we add 128 plus 32 plus 8, that's going to give us 168. Okay, that's how they got that. So if we add all this together also, we are going to get 0. And if we add this, it's just the only one there, which is there. That is 1. So this is the 1. So this is how you convert from binary to decimal, and from decimal back to binary. If you are very strong at this, then you will be strong at getting the answers to your subnetting questions. It's very, very easy. What you need to remember is 128, 32, 16, 8, 4, 2, 1. That's what you need to remember. And you need to know that's just what it is. That's just what it is. So with binary, I think let's do one last one so that I know you understand this, and then I'll stop and I'll move to the next thing. Last one. Let's do 255.255.255.0. So let's do this. My dear brothers and sisters and listeners, My dear listeners, I want you to understand that this is straightforward. This is one. Here is one. Here is one. Here is one. S1. 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 And here is one. For the second 255, here is one. 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 And for the third 255 is also 1 1. And the last one is 0, isn't it? So we have 0 0 0 0. How do I know? If you had 128 plus 64 plus 32 plus 16 plus 8 plus 4 plus 2 plus 1, that's going to give you 255. That's it. So if you add all this together, is equals to 255, and that's why we have 1 under all of them. 1 under all of them. So that's how simple IP address are. So now that I've done this, let's move back to our slides now. I'm sure by now you should understand decimal to binary conversion. Let's move back. Now I want to show you IP address range and their default subnet mask. IP address is divided into 3 classes. We have class A, we have class B, and we have class C. And the one we are going to be dealing with today, if time permits us to get there, is just going to be class C. But because we want to deal with class C, I need to show you class A and B, just introduction to class A and B. I need to do that because we are going to do class A and B later. But then I want to, because it's necessary that I do that. So class A address, anytime I need my yes, I need this now. Class A address, the default range for class A address, the default range is 0 to 127. And the default subnet mask is 255.0.0.0. So let me explain that to you a bit more. What this means, default range, it means that anytime, where's my whiteboard? It means that anytime you are given an IP address and that address starts with, remember it says 0 to 127, that's the range for class C. So this means that anytime you are given an IP address that starts with 10.0 dot any number, okay, dot any number dot dot let's say dot 0. I'm just picking any number now. Anytime you are given any IP address like this, for you to decide is this class A or class B or class C, what you need to check is the first octet, this one here. What you need to check is this number, does it fall within the range of 0 and 127? If it does, that means this is a class A address. So if you are given 1.168.120.0 or any number, then you just need to check this. Are you class A or class B? Yes, you are class A because you are in between, you are within the range of 0 to 127. If you are given another IP address, let's say 121 dot anything dot anything dot anything, you just need to check this one. Which range does it fall into? Yes, it does fall between 0 to 127. If you are given let's say 19 dot anything dot anything dot anything, this is also a class A because looking at the first octet, it is 19. Okay, it is what? 19. If you understand that, that's all I need to show you about this for now. Let's pick another one. If you are given 50 dot anything dot anything dot anything, the first range is 0 to 127. Yes, it falls there, so this is class A. If you are given 128 dot 0 dot anything dot anything, does it fall within this range? No. 128 is bigger than 127. Now you know something, this is not class A. And for your information, this is class B range. So I will explain more when we get to explaining about class B. So you understand what range means now. Now, what does default subnet means? The default subnet for class A is set to be 255.0.0.0. What does that mean? 255 here, let's convert everything back to binary, because this would always be given to you in binary, and you need to be able to convert this. This will always be given to you in decimal. That's a slip of tongue. This would always be given to you in decimal, so that we as human can read it, so that we can understand. But computer understands it in binary. That's why I've got the binary representation for it. So the binary representation for this 255.0.0.0 is this: 11111, 1 in 8 places, another 0, another zeros, another zeros. All this together is equals to 32 bits. That's why IP address has 32 bits. 32 bits. And they are divided into 8 bits each. So you have 8 bits, 8 bits with the dot. So this is 8 bits, this is 8 bits, this is 8 bits, this is 8 bits, and this is 8 bits. Okay. So when you are given any IP address, two things you have to look out for. Those things are the network address. Let me go back to my whiteboard now. When you are given any IP address, 192.168, no, yes, anything. Okay, we are in class A. Let me use class A. So when you are given any IP address, 10.10.10.20, you need to check for two things. One, the network address. And the second one will be the host address. And in order for you to know which one is the network address, which one is the host address, please, you use your subnet mask to know that. Your what? Your subnet mask. So let's say for this, we don't have any subnet mask for now. I just want to say, for now, let's say we don't have any subnet mask. If you look at this falls within the range of 0 to 127 that I said to you. Remember? So this is a class A address. If this is a class A address, that means this one here is 255. Okay, that means this one here, and when you see 255, it means that is the network address. So 10 is the network address. 10 will never change in this kind of address. That 10 will always be the same. All these are the host bits. Okay, they are the host address. So in any given IP address, you need to look for two things: the network address, the network bit, or the network portion, or the host and the host portion. So the network portion, let's do another one. Delete. If you are given 20.10.10.10, now this here, without giving any slash notation, without giving any subnet mask, because you know that 0 to 127 is what? Is your class A range. So this means this is class A, and this will be 255, yeah? And then this can be anything depending on what you are doing with your subnetting. So this means it's a 8. That's what 8 means. If you see this 8, it means that you have 1 8. 1, 2, 3, 4, 5, 6, 7, 8. Remember, if you add all this together, it's going to be equals to 255. The reason why I'm not going to do so much with class A now is because we are going to class C. I'm just introducing you to class A. When I get to class C, I'm going to explain this better. So I'm going to leave this. Even if you don't understand it, don't worry. Leave it. Let's go on. So the subnet mask, I'm coming. So the binary representation for this subnet mask is, you can see, is either you are given subnet mask as this or as this slash notation. They use either of these, so be expecting one of them. So if you are given /8, I prefer to be given /8 because that makes my life easy. Once you are given /8 or slash notation, it means that they're saying to you the first 8 bits are ones. 255 means also that the first 8 bits are ones, because if you add 128, 64, 32, 16, 8, 4, 2, 1, you are going to still get 255. So with number of subnets and number of hosts per subnet, I'm going to do that when we get to class C. Let's move on. That's class A for you. Now class B. In class B, I'm just going to say the same thing. The range of class B IP address is, the default range for class B is 128 to 191. And this means that you are going to have 255.255.0.0, which is /16. And that tells you /16 simply means that you are going to have the first 2 octets as what? As ones. Because if you add all these ones together, it gives you 255. You add all these ones together, it gives you 255 as well. So let me use my whiteboard again for class B. So for your class B, remember the range for class A is 0 to 127. The range for class B is 128 to 191. And this means that if you are given any IP address starting with 128 dot anything, 128 dot, let's say, dot 10 dot anything dot anything. So 128 dot anything without any slash notation. This, checking it, this is a class B, isn't it? It's class B range. And since this is class B range, we know that this is a class B address. If you are given, you are checking the first one, okay? You are just checking the first, you are only going to be checking the first octet. If the first octet falls within the range of 128 to 191, then you are going to be in class B. Let's say you have another IP address that says 140 dot any number dot any number dot any number, that's going to be class B also. If you say 171 dot any number dot any number dot any number, just looking at it, ensuring that it falls within this range means this one is class B also. Any number 160 dot any number dot any number dot any number, that is also a class B. 133 dot any number dot any number dot any number, that's also a class B. I'm sure you understand by now. So let's go back to our slides. Now that we understand that, we want to talk about the subnet mask, the default subnet mask for class B address. So the default subnet mask for class B address is 255.255.0.0, which is the same thing as 11111111111.0, because with 16, always remember this. What 16 means is that you have, it means that you have ones. It means that you have 16 ones. It just means that you have 16 ones. Don't disturb yourself. Once you see this last notation, it means that you have 16 ones. And I will always say, whenever you are told the number of ones you have, even when you are subnetting, that tells you don't touch those ones, just leave them. Those numbers remain the same. So I'll get there. And I'm going to explain this and this when we get to class C, because it's class C we are going to be dealing with extensively. So I want to go to class C now. Yes, we get there. Please get ready. Please get ready. So with class C, class C IP address starts from 192. Class C IP address starts from, I'm going back. Class C IP address starts from 192 to 223. And the default subnet mask is this 255.255.0 and /24. Remember this by now. /24 means you have 24 ones. This is 8, another 8, another 8. If you add them together, that's 24. So this is what slash notation does. This is what it does for us. So let's go. Let me go back to my whiteboard now. Remember, class A starts with 0 to 127, and the default subnet mask is 255.0.0.0, and this means that you have 8 ones. Class B starts with 128 to 191, and this means that you have 255.255.0.0, and this also means that you have 16 ones. Okay, and class C now starts with 192 to 223, and this means that you have 255.255.0, and this is what /24. This tells you have 24 ones. So this is what all these things, this is what it all means. Now you can see class A has 8 class A has 8 ones, class B has 16 ones, class C has 24 ones. So this is what it all means. So I'm going to just clear everything now. So let me go back and see what more to talk about. So if you understand all these ones now, let's move to this now. Let's discuss this. So remember, in IP addressing, when you are doing IP subnetting, you want to calculate the number of subnets that you can create and the number of hosts you are going to have in that subnet. What do I mean by that? So if you are given, let's say you have a router, this is a router now, and you have a switch, yeah, a switch, and you have computers connected to the switch, sorry. These are computers. Let's say we have 24 computers here. Let's say we have 24 computers. So if you are given one IP address to share with this, and you are given 192.168.10.1, you are going to be told in all questions, you are going to be told either you are going to be given that you use this subnet mask 255.255.255.0, or you are given slash notation. This one now, the slash notation is 24. So if you are given this thing, you're given this question, yeah, normally by now I want you to always know that 255.255.255, we need to convert this to binary. But what they are telling you is you do not need to convert this to binary, the first 3 octets, because we have done it for you. Because they are 255, it means they are all ones. So we have 24 ones already. And you see, this here should also tell you the same thing, that you have 24 ones in that address. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24. Yeah? So now they are telling you anytime you see ones, just leave it, don't touch it. Don't touch it. So if you are not going to touch it, you have to bring 192.168 the way you are given at the top here. .10, you bring it back here. Dots, and this means all these things that are the same thing, yeah, that they are ones, they are your network address. They are your what? Network address. That's what I was trying to explain. All this thing here from that they told you is 255.255. That means they are telling you you don't need to convert them. Leave them as they are. Don't touch them. That's the rule. But you see this one that we say is 0 here. This is the one you can start playing with. Yeah? You can start playing with this. Do whatever you want with the ones here. But these ones, don't convert them. So let me go back and explain that with my I want to explain this with my, what's it called, with my Microsoft Word. Let's go to Microsoft Word again. So what I'm saying in essence is that if you are given an IP address as 192.168.10.10, anything, this is an IP address now. This is an IP address. What would you say to this? And they gave you a slash notation. Let's say the slash notation is 24. If they give you 24, what they are telling you is you have 24 ones. So they are telling you, please, you see this four, the third, this 3 octets, sorry. These 3 octets, 192.168.10, don't subnet them for us. Leave them as they are. So what you are going to have is 24 ones. I'll do that now. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. This is what? This is already 24 ones. Yeah. So what I can do to make you understand it is move this to here, and move this to here. One more, and move this to the last 0. This is what this means. So they are telling you 192, leave it. 192, don't touch it. Okay, don't touch it. They are telling you 168, don't touch it. They are ones, leave them like that. And they are telling you 10, don't touch it, leave it like that. But this last one, this last 10 here, they are telling you you can do whatever you want with that. So if we are going to rewrite this out in subnet mask, we are going to say this is 255. 255. Dot 0. Do you know this is what we are going to have? Because if you add all these ones together, I think we've done that. Look at it. If we add all these ones together, we are going to get 255. 255. Because these are the ones. You add them together, you are going to get 255, and the last one is what you can play with. So please get yourself ready and be easy with IP addressing. Don't disturb yourself too much, because they will always give you something to help you. So let's try another one. If we are given 10.10.10.10.0, I want to be using 10.10.0. If you are looking at this now, you know this falls between 0 to 127, which is a class A. But we are not dealing with that again. We are dealing with the slash. So let's say they gave us, they now say our subnet mask is 255, 255, 255. And if they say this is, I don't want to use 255. If they say here it is 224. Do you know what this means? Let's find out. This means that you have 1111, 1, 2, 3, 4, 5, 6, 7, 8, because 255 simply means 11111. Do you know that? I've explained that to you. Another 255. So another 255 simply means 1111, 1111. That's the second one. And the third 255 simply means the same thing, 1111, 1111. And the last one, instead of them putting 0 now, they said it's 224. what can we do to get 224 if we come back to our binary here? If we want to get what's it? Yeah, is it 224? Where's the number again? Yes, 224. If we want to get 224, where's my calculator? What do we have to do? So to get 224, let me first take this out. Okay, so we want to calculate 224 now. Come up. So I will now say, to get 224, can 128 go in 224? Yes. So 224 minus 128. I'm left with 96. So this is going to be 1. Okay. My calculator, I'm left with 96. 96 is bigger than 64. So 64 can go in 96. So minus 64, that's equals to what? 32. So I'll move down there and put a 1 there because it can go. And I'm left with 32. And that is 32. So that's going to be 1. And others are going to be zeros. If you add all this together, 128 plus 64 plus 3 plus 32, you are going to get 224. So what they have done to us here is to say, here we are going to have, how many ones is that? How many ones? We have 3 ones and 5 zeros. So you are just going to come down there and say, we have 1, 2, 3, 1, 2, 3, 4, 5. And that's what they've done for you. And if you want to know that we are correct, let me bring this down. And if you want to know that we are correct, what we have to do is add this together, is going to give us 255. Add this together, is going to give us 255. Add this together, is going to give us 255. Add this together, is going to give us 224. And if you can't, now let's do our slash notation. The slash notation is 8 plus 8, 16. We have 16 ones. We have, let me count it now. We have 1, 2, 3, 4, 5. We have 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27. So this is a slash 27 slash notation. I don't know if you understand this logic, but this is the simple way I can explain this. This makes our life so easy. This makes our life so easy. So let's go back now. If you understand that, let's go back here again to our slides. So now that we understand this, so I'm just saying, anywhere you see 255, it is all ones. 255, it is all ones. 255, it is all ones. And you can see it's equals to 24 ones. That's why we have 24 ones here. That's what that is. So apart from that, once that is gone, now the next thing that I haven't explained before that I would like to explain here is number of subnets. So this is a formula we have been given, and there's nothing we can do about this formula. We have been given a formula. The formula to solve this problem, to solve the number of subnet and the number of hosts, is 2 raised to power n. 2 raised to power n. So if you are calculating the number of subnets, you are going to do 2 raised to power n. So let's use this as an example. What is 2 raised to power n? 2n now, n is the number of zeros we have, okay? N will always be the number of zeros we have. So in class C, you are going to say 2 raised to power 8 because in default class C address, you are going to have 8 zeros. So you are going to say 2 raised to power 8. And if you are going to do 2 raised to power 8, yeah, if you are going to do 2 raised to power 8, if you are going to do 2 raised to power 8, then let's go back to our powers of 2. Look at the powers of 2 here. 2 raised to power 8 is 256. So this tells you that if 2 raised to power 8, 2 raised to power 8 raised to power 8 is equals to 256. So this is how you calculate the number of subnets you are going to have. Number of subnets you are going to have. I'll explain that later, but just know that formula. If you are told to calculate the number of hosts you are going to have in each subnet that you've created, that is 2 raised to power n minus 2. So in class C, remember, if we go back to our slides, if we go back to our slides, in class C, we have 8 zeros, isn't it? We have 8 zeros. Remember, 8 zeros. So we are going to take 2 raised to power n minus 2. So if that is, remember, 2 raised to power 8 is 256. Minus 2 will give us 254. So this is how you calculate this. It's permanent. It's never going to change. That's the formula. It's never going to change. So we are going to use this very much. Let's leave it for now, but I just want you to have that at the back of your head. So one thing I want you to know when you are calculating IP address again is that all ones, anywhere you see ones, they mean what? They mean network address. Anywhere you see zeros, they mean what? Host portion, because IP address is divided, an IP address, any given IP address is divided into 2 portions. We have the network portion, we have the host portion. And this is what will help you to know which one is the network portion, the 255.0 or the slash notation. This is what will tell you what your network portion is. In this case, because we have all 24 ones, all ones are your network portion, all zeros are your host portion. So that is what this is saying to you. Let's go back one bit. Let's go back to class B now. How do we know which one is our network portion and which one is our host portion? Do you see it says by default is 16 ones. So here is your network portion. From here is your host portion. So if we go to class A also, we are going to see that, where's class A? If we go to class A also, we are going to see that all ones is our network portion, all zeros is our what? Host portion. And the formula works the same way here. So now that we've done that, let me see what's next I'm going to show you, because we are getting there now. All those ideas, we'll have to bring them together and then work out how we calculate our IP addressing. So let's go, we've done this. Now, if you are smart, please, and I know everyone that will be watching this must be smart, because IP address is not for people who are not smart, even though I'm not smart. So look at this. You can take a picture of this page and hold it. In order for you to be good in subnetting, you need to have like the ability to okay, let me read it. The ability to subnet depends on your binary skills. If you are good at converting decimal to binary that we did, you are going to be good. If you know the powers of 2 very well, 2 times 2, 4 times 2, 8 times 2, 16 times 2, 32 times 2, 64 times 2, 128 times 2, 256 times 2, 512 times 2, 1024 times 2, 2096 times 2, 4000, all those things. If you know them, then those are power of 2. You are going to be good. Now, these are called your subnet mask. You see this? They are your subnet mask. And subnet mask will always be this: 128, 192, 224, 240, 248, 252, 254, and 255. You will never use these two anyways. You will never use these two. So how do we come across this number? You know, like I used to say, IP addressing is what? Is copy and paste. You just need to figure out how do they all work together. All these things, they are there. All you have to do is cram this thing, understand when to use them. So 128, I got 128 from here. How do I get 192? 128 plus 64, 192. 192 plus 32, 224. 224 plus 16, 240. 240 plus 8, 248. 248 plus 4, 252. 252 plus 4, 254. 254 plus 1, 255. So these are what I want you to understand. And now we are going to start subnetting class C. This is all the explanation I have for you, and I have spent 1 hour explaining so that you get things all together. Yeah, I've spent 1 hour explaining this so that you understand and you get things done, and then we are going to start subnetting now in another video. Thank you for watching, and then let's go and start subnetting. Please take some sip of water before you go to the next video. Thank you.